Hello everybody. In today's lesson, we're going to look at applications of quadratics. So, review of a lot of the skills that we've covered in quadratics, and just specifically in a sort of a real world kind of application. So, I'll go through a review of the skills, and then you'll see them in action in an application question. And then there's the assignment sheet for you to submit. Just 2 questions. Not too much. So with this question here, let's go second page. There's a blank page for you to work from if you want to print out the sheet and try it first. Let's make room though for answering here. Probably don't need that much room. Anyway, so just from this form of the quadratic given, it was given in vertex form. So stating the vertex is really quite easy. So the value of the vertex would just be opposite to this. So the x of the vertex would be the -4. That's just something we know. And the y of the vertex would be also -4. So state the value of the vertex. The vertex is, right, the vertex is -4, -4. And that's all would be needed for that one. Just a known thing in that format. So let's move back up a little bit here. And we're going to convert to standard form. We've got that much room. Convert to standard form by multiplying out and collecting like terms. So let's do that. Y equals x plus 4 squared minus 4. So to do that, we're going to recognize that the square means, of course, x plus 4 times x plus 4. Then we're going to do that multiplication, which is a previous lesson, just a binomial times a binomial. So that stuff is, I'll just do it in green to be good color coding here. X times x is x squared. X times 4 is 4x. 4 times x is also 4x. Just rearrange to be the same order there, number and then variable. And then a 16. So that's that stuff. A -4. We're going to collect like terms and so on. Right? So together there, we're going to have 8x. We'll have the x squared, 8x, and then 16 take away 4 would be 12. Okay, so that's standard form from that. And the nice thing about that is now the y-intercept is obvious, right? So the y-intercept is right here. Go different color here. Let's go right there. That's the y-intercept, right? The y-intercept equals 12, just a known thing from that form of the equation. I think I'll just keep going because this is going to be printed as a full page PDF. So I'll keep going down the page here. If we're asked to factor that quadratic, so let's, now that we have that standard form, let's see if that's a piece here that I could grab. Perfect. On that one. So we have this quadratic. And so if we're looking at factoring it, we're looking for n numbers of 1 and 12. Looking for factors of 1, 1 and 1, factors of 12 that'll add to give 8. And so instead of choosing at random a 4 and a 3 or a 12 and a 1 or a 6 and a 2, we could choose a 6 and 2 knowing that it's going to work. In the cases where you have 1s here and here, it's easy to do that. So 6 and 2 adds to 8. Yay, we have the right numbers. So the factored form is a 1x and a 1x and a 6 and a 2. So if we are keeping practice with the idea of something having to match up, the first one has to multiply on a 6. Obviously, the order doesn't actually matter here. But good to be able to do that if when it's needed. Right? So if you always do it, it always happens. Don't forget in the harder case. State the x-intercepts. So for the x-intercepts, we would let this thing be 0, right? So for x-intercepts, we're going to set y equal to 0. So we have a 0 equals that factored form. Oops. rewrite that so it looks a little better. Plus 2x plus 6. And so we could go through the whole process of saying this is 0, and having our x plus 2 equals 0, and then adding 2 to both sides, or taking away 2 from both sides. End up with x equals -2. Or we can just use that, knowing that the brackets give you backwards results, and just say, oh, we know the answer is going to be x equals -2 directly. Same thing for here. X is going to be -6. So we have zeros of -2 and -6. And then after all that, this question just says to graph based on the results from A to C. We also could have graphed it based on transformations as well. So we can maybe talk about that afterwards. So basically, I maybe should use the word sketch because I'm not necessarily going to do a full detailed graph. So I have one nearby here. Yeah, I'll just do a sketch of this. I'm just going to grab a grid from another file if I had one open. So here we've got that. So we know the zeros we already just recently looked at is -2 and -6. So let me move my y-axis over a little bit. So -2 and -6, 3, 4, 5, 6. So zeros would be there. We know the y-intercept is at 12, and so maybe I will modify this as well. Like that. So the y-intercept is up here in purple, so I'll do purple again. So way up here at 12. Not drawn necessarily to scale, but just getting the ideas on the page, right? We have a y-intercept there. And that's all we know so far, or the vertex actually is -4, -4. So vertex, -4, 1, 2, 3, 4, and 1, 2, 3, 4-ish. Right, so based on all that stuff, graph the quadratic based on those results. So we have a vertex even, we've got a y-intercept there, and yeah, going the other way, same shape. Right? If we look at that result based on what we were given, let's make a copy of that thing. So if we compare to what we started with here, does it match everything that it should? Is it to the left 4? You're like, that's supposed to be a question mark. Left 4? The answer is yep, there it is, left 4. So check. Is it down 4? Yep. And is it the original shape? Yeah, it is actually, right? You can see we went over 2 steps. Well, the only next point we know is over 2 steps up 4. So that's the right shape as well. So the over 1 up 1, and then the over 2 up 4 shape matches as well, right? And so the last step was graph both forms using technology and show how they compare. Of course, they're going to be the same. So let's just do that. Go in here, go to GeoGebra, and we're going to graph each one. So we're looking for the original one, x plus 4 squared minus 4. There's the graph, and it looks just like the one we drew. If I zoomed out, we can even see that 12 up there. And the other one we're going to graph is the x minus 4, no, x plus 2 and x plus 6. So x plus 2 and x plus 6, x plus 2 and x plus 6. And boom, it snaps into the same spot. And you can see the colors here. Like if I show the green one and then show the blue one, they're in the same spot. Okay, so this result, screen captured into your submission as well if this is a submission one, so I can see that you know how to do it. Some people haven't been doing that for me, and I've been commenting in the feedback from assignments. Even if you just take a picture of the screen, just like you take a picture of your page, that's totally fine. Might be easier to make it all one file. Yeah, there we go. So that's done. Yeah. And then the application version of this, you're going to see some major similarities here. Okay, so there's blank pages to work from as well. But you have this equation of a cannonball fired, and I left it as x seconds. The h is the height. That could have been y, meaning the height, and so on. I quite often would have a t for seconds, but it was just as an x, so I just left it as that from last time I used this. Anyways, so there we go. There's your definition. There's the equation, and then h is height meters, and x is the time in seconds for this cannonball that's been launched. So we are going to use that given vertex form to answer some questions. So the answers we can get right from the form given would be the maximum height of the cannonball. So the maximum height of the cannonball would just be this y value from the vertex. So we can say right away, just from that, the maximum height is 65 meters, since the vertex, the y value, h or y value of the vertex, visible from vertex form, obviously, is 65. Okay, so that's number one. Number two, it says how long does it take to reach that maximum height? Right? How long does it take to get to that maximum height? Well, we know that the vertex is over the vertex is at +2, right? So right here we can say it took 2 seconds to reach the maximum height. Since this is like justifying, right? Since the x value, so the x value, which of course is the time value, right, of the vertex, is 2. And I'm not looking for any justification beyond that, like the math of it. We just know it's opposite, right? So we'll just say it. From that, we should just say the vertex, the x of vertex is 2. That's the only justification I'm looking for in that one. No calculations or anything. Next question was to convert to standard form, and then based on that, we could answer what the initial height was. Okay, and that's because when we multiply this thing out, we get standard form, and standard form always has that initial height at the end, which we called the y-intercept originally, right? So in an application question, instead of saying what's the y-intercept of the cannonball, they say what was the initial height. Okay, so we're just sort of getting a chance to see how, or what kind of wording is used, right, for the application version of the math processes that we know. So here we go. We have an x squared, we have a minus 2x, another minus 2x, and a minus 2 times minus 2 is a plus 4. So that's that stuff. We have the 65 tagging along. So we have some more work to do here. Let's collect those like terms first, just to simplify things. So I have a negative 4x plus a 4, well, 65. And then, of course, this minus 5 has to multiply on each of those. Same idea, the distributive law. So we have a minus 5x squared. We have a plus 20x, because negative times negative is positive. 5 times 4 is 20. And a minus 20 and a plus 65. So that gives us in the end here, the 20 takes away from the 65, giving 45. Okay, so therefore you can see the initial height is or was or whatever, 45 meters, I think, right? Yeah, 45 meters. And again, we could say since the so-called y-intercept visible from the standard form is 45. Okay, that's easy, hopefully. And then the last step here, convert to factored form to answer the question, how long was the ball in the air? Okay, so these questions would be specially created so that they are factorable, since we're asking you to solve by factoring. Sometimes quadratics aren't factorable, and there's other processes to solve for zeros in that case. So let's do this for now, though. So we're going to convert to standard form. So we're going to multiply this stuff all out. Show that it's this. Third factored form. Oh, actually, I was like, this seems familiar. Just did this stuff. We should start with that standard form version. So that thing there. So we have h equals. Let's see if I can just grab that. Don't need to do that process again. We just did it. So let me just grab that. So we've got more than we need here. There we go. So we've got that standard form to factor. To work with easier numbers, you could divide out the 5 and divide out a minus 5, I should say. And so we get out front a minus 5, and inside we have, it looks like a 5 instead of an S. We have the x squared, we have a minus 4x, and we have a minus 15. Okay? And so we're looking for factors of that, right? So we're going to look at the n numbers of 1 and minus 15. And we're going to get factors of 1 and 1. And yeah, so we have, actually this one, I might have messed up. This one does not appear to be factorable. It was supposed to be. What have I done? 15 and 1. So if this thing was factorable, you'd have the factored form, you'd be able to get the zeros. But it doesn't appear to be. Let me just look into something. I'll just pause us for a minute. So the good news is I'm back here after pausing. It was instant for you, I'm sure. But good news is I found a mistake. So this is actually minus 9. And I was like, hey, it'll probably factor now, right? But the bad news is it still doesn't factor. So it just is what it is. Not all things are factorable. So if this one was factorable, which I kind of meant for it to be, we would have been able to get zeros, right? So plus number and whatever these would have had the zeros directly from it. We'll need to redesign that question for next time, but not going to do that right now. So those are the key skills, though. Hopefully the authors of these questions, where I grabbed them from, thought it through carefully enough and didn't make a mistake like I did. But yeah, so you're going to be able to put in standard form. Once it's in standard, actually they're not asking you for the when it lands. So I'd be curious, and is this factorable? And get the zeros and when it lands as an extra question. So I'll put that in for you to do, because it's just the big picture of all the things, right? This one obviously is factorable because it was given in factor form, so you would just those directly, I guess, right? Those x-intercepts and so on. What do they mean and so on. So some of the stuff in each of those questions. And I guess that's it for now. Right? So that first question, first page for you to submit as an assignment. There we go. Bye for now.